Assalamualaikum warahmatullahi wabarakatuh. My name is NURIN BINTI HAMID. I will go ahead and make assignment to survey the cooling system at Eco Bakery Segamat. Before I continue this presentation, these are my group members. The location of Bakery Segamat is located at A008 U Central Jalan Utama 3/2, Taman Utama 85000 Segamat, Johor. The bakery is operating from 10 AM to 10 PM every day. Our observation time is from 12:30 PM to 1:30 PM. That take 1 hour of observation. The bakery have one server during this observation conducted.
Okay, for my part, I'm gonna explain about the characteristic of a queuing system, namely the arrival characteristics, waiting line characteristics, and service facility characteristics. We're gonna start with arrival characteristics. Arrival characteristics have three major characteristics, which are size, pattern, and behavior. For Eco Bakery, the size of the calling population is unlimited, which is also known as essentially infinite. For the pattern arrivals, we found that the customers arrive at the shop randomly, which is unpredictable. Hence, we can say that it is actually generally following a Poisson distribution. Lastly, for the behavior, we found that majority of the customers in the Eco Bakery are patient and wait in the queue until they are served. However, there are a few of them who follow the terms reneging, where they already enter the queue but become impatient and leave the system. Now, I will continue with waiting line characteristics. The length of the line is unlimited, while the term first in first out, or we call it FIFO, was applied once the customers are in the queue to pay. Last but not least, service facility characteristics. Eco Bakery use a single channel and single phase system, where once the customers arrive, they will choose their bread according to their preference. Then, they will queue in the line to make their payment. They will then exit the Eco Bakery once the payment have been made. That's all for the characteristics.
I will be explaining about calculation of queuing model. So, the first step is we must get our lambda and mu, and our lambda is 17 customers per hour, and for our mu we can calculate by adding all of the time spent for each customers and divide it with 17 customers. So, the next step we will get 1.35 minutes, and 60 minutes we must divide it with 1.35 minutes per customers, and we will get 44.44 customers. So, for our mu, we will get 44 customers. So, the next step, after we get lambda and mu, we can calculate the average number of customers in the system. As you can see in the formula, we get lambda divided with mu minus lambda, which is equals to 0.63, or 17 over 27 customers. So, the next, we can calculate the average time of customer spent in the system, which is W equals to 1 over mu minus lambda, which we will get 1 over 27, or 0.037 hours, and we can convert it with 2.22 minutes.
Next, we move to the average number of customers in the queue. We use the formula, which is LQ equal to lambda square divided by mu times mu minus lambda. So 17 square divided by 44 times 44 minus 17. Then we get 0.24 customers. It means that there are 0 average number of customers in the queue. Next, we move to the average time a customer spends waiting in the queue. We use this formula, which is WQ equal to lambda divided by mu times mu minus lambda. So 17 divided by 44 times 44 minus 17. Then we get the answer 0.014 hours. To change in minutes, we need to times with 60. So we get 0.84 minutes. It means that the average time a customer spends waiting in the queue is equal to 1 minute. Next, we move to the utilization factor for the system, which is the probability the service facility is being used. So we use this formula, which is rho equal to lambda divided by mu. Then 17 divided by 44. So we get 0.39. Then the answer is 39%. It means that 39% of the service facility is being used. Next, we move to the percent idle time, which is the probability no one is in the system. We use this formula, which is P null equal to 1 minus lambda divided by mu. So 1 minus 17 divided by 44, then we get 0.61. Then the answer is 61%. It means that there are 61% probability of no one is in the system.
Regarding in our project, the number of server provided at the time is adequate because the rate of service per server, which is mu, are larger than arrival rate of customer, which is lambda. So based on the answer above, the customer are happy with their waiting time because they do not need to wait for a longer time. For the last question, what we have learned from this project are queuing theory is very important to determine how much server is needed to serve the customer. So, when the waiting time for customer is shorter, they will be more satisfied. That's all from us. Thank you.